The next part of our introduction will be an introduction to geology itself. We took in the first part what is the relation between geology and geotechnical engineering. And we said why is geology a science and geotechnical an engineering? And what is the link between geology, hydrology, and geotechnical engineering? So the summary of what we took in the first part is the link between geology as a science, hydrology as a science, and geotechnical engineering as engineering, not a science. This part of our lecture will be dedicated to geology. What is geology? We need to introduce students to understand geology. Of course, as a geotechnical engineer, when you graduate from this college, you will be an engineer, whether geotechnical or structure or whatever, but you will not be a geologist. So this course is not intended to understand what is geology, but it is intended to understand what is geology important, why is geology important for geotechnical engineers. So this is what we are going to understand. Plus some information that is important as a general knowledge. You may not use it in your work, but it is important for you as an engineer to have a good background in geology. But we are not going to go any deep in geology, just the cover of the geology, or the small part of the geology, the introduction for the geology. So we are going to take basic information for geology, understand the composition of the earth. We are building on earth, so we need to know the composition of the earth. Understanding geological processes that shape the outer surface of the earth. The outer surface of the earth was not created in one time. This outer surface of the earth was not the same millions of years ago. It changed. So why it changed, how it reached us? Of course, this is very important for geologists, because geologists tell you 5 million years ago something happened, and 4 million years ago something else happened. For us, I don't care. What I care for is now. This soil now, what it is, what is the properties of it, and how can I put my building on top of it? I don't care the life history of the earth. What happened is not important for me, but I will only take what is important that affected my soil to reach this condition. I will give you an example. Volcanoes, you all know what is volcanoes. When volcanoes erupts, the earth is covered with lava. Of course, it changes the structure of the earth, because you have sand, clay, and then it is covered with another type of soil, something coming from the inner part of the earth, and then cools on top of the earth. It's another type of rock. It's called igneous rock. So another type of rock was brought from inside to the outside. Can I use it? Can I put my building on it? Is it safe? Is it not safe? This is what's important. But the geology will study the chemical formation and how this happened, and for me it's not important, or for all of us it's not important. Providing basic information of the internal Earth process. We will take just minor information of the internal Earth process. What is happening inside the Earth? This is what I was telling you. It's not important for me to understand. We'll have introduction, geology as a science, branches of geology, and so on, definition of geology. This is very important for us. Earth internal structure, it is important to know what is inside the Earth. Composition of material. Now we are dealing with material, sand, gravel, rock. How it came, I have to understand. Is rock different than soil? Do you know that both are related to each other? I'm asking now. Do you know that rock is related to soil? Do you know this, or you don't know it? Yes, yeah. You sometimes dig, you find soil, and then beneath the soil you may find rock. But actually, this soil on top was once, long time ago, was rock. But something happened to it. It weathered, disintegrated, and changed into this. So we have to know how this happened. But this is for our information. But if I'm going now to put my building on top of soil, do I need to know that it was rock a million of years ago? No, I don't need. But this is very good background information for you as an engineer. Earth geologic structure, this we are going to study. Weathering and erosion, this is very important. Weathering and erosion, because you will study how rock weathered to be soil, or how soil weathered to be another type of material. This is something. But as I said, it's not very important for me, but it is important because this weathering may happen during the lifetime of my building. Suppose I'm putting my building on a type of material, and this material may be affected by the conditions around me, and it will weather. And if it weathered, then it will not be suitable to put my building on top of it. So weathering and erosion is very important. Erosion, suppose I'm putting my building next to the river Nile, and this river Nile is eroding the soil. Maybe one time I find my building inside the Nile because the Nile eroded the soil below it. So this is important to know, weathering and erosion. External geological process and internal geological process, this is something we are just going to take minor information about it as a geotechnical engineer. As a definition, what is geology? Logy, which is geology, hydrology, anything ending with logy, it means, this is a Greek word, it means the study of. So geology in Greek, it means earth. Hydrology, it means water. So if I say hydrology, it means the study of water. Geology is the study of earth. Geology is the science of earth, dealing with its composition, structure, and geological history, as well as studying the origin, properties. This is important. Origin may not be important for us, but it affects the properties, because if I know that this soil, the origin of this soil is a very strong rock or a strong material, then the properties will be very good. But if the origin is weak material, then the properties will be very weak. So it is important for us just to know the background. But properties, I can measure the properties. If I take a sample and send it to the lab and determine the strength of the soil. I don't care if this soil was 1 million years ago was very strong or not very strong. What I care for is what it is today. So it is today. I can prove it by taking samples and testing it in the lab. Composition of both rock and minerals. We'll also understand what is the difference between rock and minerals. Do any one of you know by chance what is in our life, what is different between rock and minerals? Rock, we see rock everywhere, but minerals, sometimes they tell you, eat this food, it is full of minerals. So minerals is, of course, it's not rock, but minerals means what is the composition or the base of this rock. Before being rock, it was minerals, and these minerals consolidated together to be this type of rock. So rocks and minerals in soil, they are both linked to each other. If I tell you this is the property of rock, it may be also the property of the mineral, but rock may be a combination of different minerals together, so it may be the properties, the combined properties of all of them. Geology also studied the Earth's history since birth, 4.5 billion years ago. Of course, as a geotechnical engineer, we don't care a lot about this. Process that have shaped the Earth, oceans, and the interior of the Earth. Why we study Earth or geology? We study Earth for valuable resources such as soil, water, metals, industrial minerals, and energy. Anyway, we said this in our introduction, so we are not, and this is mainly geology. We are not going to concentrate on this now. Why we are studying Earth and geology? Of course, this is similar to what you have seen in the first part of the lecture. We are studying to avoid something like this because geologists can study the below of the soil and tell me that this soil or this rock can collapse and take everything on top of it. Volcanoes, I have to avoid volcanoes. This also may be something like failure, slope failure or something like this. We said this in details in the first part. Now, what are the basic branches of geology? There are lots of branches. Physical geology is what we are dealing with. But all of these, they are very, very good. Remote sensing, geophysics, remote sensing and geophysics. I showed you in the first part of the lecture that we can do some kind of ultrasound for the soil. These both branches help us to understand remote sensing and geophysics. The applied branches is this branch. This is the one that we are interested in, engineering geology. Engineering geology, all the other are, you can just know it for info. But engineering geology is the part that we are interested in. Let's skip this. This is recommended readings. I will tell you exactly what is oriented to our study this year. This is important. Important not because it will help us as a geotechnical engineer, but important as a very good background engineering information for us. The Earth, suppose that this is the center of the Earth. If this is the center of the Earth, and this is the surface of the Earth, and then it is divided into these things. The inner core, or let's say the core, because the core is a very, very hot سطح الارض من جوه بقى. تخيل ان انت حفرت جوه 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 لحد ما تنزل ما فيش يعني ده استحاله حد يقدر يوصل. Nobody can reach to this level. We are just playing in this top portion, but all of this we cannot reach by drilling. So here is the core. The core may be divided into two portions, inner core and outer core. Then we have the mantle. The mantle is on top of this on this core, and here we have the crusts. The crust, we can divide it into a few terms that you have to understand. Of course, you know what is atmosphere? Atmosphere is the air around us. But if I say hydrosphere, it's another geological term, but it means it is related to water. It is the part that is related to oceans, seas, rivers, and all of this. Then I have the biosphere and the lithosphere. Of course, these are all geological terms. I will give you in the next lecture something like a table that you can differentiate between all of these. They are related to soil and water. Is this related to a solid part of the soil or part of the soil that is full of water, or just partially full of water? These are the ideas that we are going to check. This is a very good thing, and of course it is one of the questions that usually come in exams, so you have to concentrate on this. The Earth, this is the inner core, followed by the outer core, followed by the mantle, followed by the crust. Everything we do and drill is in the crust. Imagine the dimensions. This crust, this is what we are studying as a geotechnical engineer. But all of these are being studied by the geologists. So we are going to take from them what we need. No, because it means that we have to penetrate the mantle. And this is a lot. The deepest borehole that was taken is in Russia. I can give you more information about it, how deep it was. I think it was 1,300, something like this. This is the maximum. And the problem with them is the deeper they go, the hotter it is. It's very hot because the temperature of the inner core is approximately like the sun. Imagine the sun, that we say that nobody can reach the sun because, not because of the distance, but mainly because of the temperature. Nobody can reach near to it. The temperature of the sun is below us. But that's why the inner core is melted. It's like a soup, but a very, very very hot. Nobody can reach it, or nobody can endure this temperature. The outer core, this is related to it, but it is little bit solid. The other is melted. The mantle is the start of the what we call rock. Here, because of the temperature, we don't see rock. But starting from the mantle, we can here a definition. The core, small innermost layer composed of Fe and ferrous and nickel, and solid. The outer core is liquid, responsible for the Earth's magnetic field. I think here is something mixed. Outer core is liquid. The outer core is liquid. So, anyway, so it means that the inner and outer core are still liquid. The mantle, upper and lower, we have two layers, upper and lower mantle. A thicker layer dominated by silicates, but including heavier material. Anyway, so it is the start of the rock. We are now speaking about the material that will be composing our rock. The crust, thin outer layer composed of most of Si and O, silicates, rocks. So here, the crust is the rocks that we are dealing with in our daily life. This will, the crust is about 100, just concentrate with me in this number. The crust is about from 0 to 100 kilometers. And we said that the maximum that we can reach by drilling is 1 kilometer or 1.5 kilometers. So we are on the top portion of the crust. So the mantle is very far away from us. So the crust, then we have the mantle, outer core, and inner core. You will have in this course to know these layers, the approximate thicknesses of this layer, just to know that we are, as a geotechnical engineers, what we are dealing with, and the geologists, what they are dealing with, so that you won't, in your future life, not every geologic book you will be interested in or you will understand, because they are concentrating on their field and we are concentrating on our surface of their field. So it is not, we are linked together, but there are parts that we don't understand in what they say and they don't understand in what we say. So we have to know what is between us. Let's skip this for this session. We'll discuss it the next lecture. Here, we said that we can understand or do some kind of ultrasound or sonar to check what is below the ground. Of course, we, as geotechnical engineer, we have our type of ultrasound and sonar. Because, as we said, we are interested in maybe 100 meters below the ground. But geologists are interested in much lower layer. Do you remember in the last few days, there is the post that maybe I think most of you have seen. They are saying that the inner core of the Earth has stopped revolution, and they are saying that it may turn in the other direction. You've seen this post? Anyway, you will see. Search the net for something like this, and you will find something they are relating this to there will come one day that the sun will rise from the other direction and something like this. But regardless of this, I don't believe that this is happening, because the inner core, according to geologists, may stop, may revolve and revolve again. This is something. It does not mean that the full Earth is will follow the same pattern. But anyway, what I need from this, how did they know? If we are saying that we are, the crust is 100 kilometer, and we are studying only 1 or 2 kilometers as a geotechnical. So how they knew that the inner core or the core itself stopped revolving? It is using special types of wave. It's not like the ultrasound that we do for sonar, or not the seismic investigation that as a geotechnical engineer we use for the soil. It's a different type. There are two types of waves. You will get to know it later in other branches of engineering, but there is something called the P wave and the S wave. S means shear wave, P wave means pressure wave, the different meanings, but what I need you to understand that when I'm using waves to check the below ground, I have two types of wave. One of them is called S wave, and the other is P wave. When these waves, when you start inducing it on top of the soil, the S wave will stop here. What is here, this level? It is the outer core. Why? Because the outer core and the inner core are melted. They are molten. So this wave do not propagate unless they go into solid particles. So here we don't have solid particles. So this is the end of the S wave. The P wave can go, but with a different velocity. When it goes with a different velocity, then these types of wave, when they induce it on top of the soil and collect or receive the waves back, they can analyze this wave to see how long did it take to go down and get to the top, so they can measure distances. What is the thickness of the mantle? What is the thickness of the outer core? What is the thickness of the inner core? All of this they can measure using these types of wave. So this chart shows you here is the temperature. If we are saying that here 0, suppose that you are at the North Pole and this is a 0 degree. In the crust, the temperature increases till it reaches, here it's 1000. That's why I tell you that when they try to dig into the ground, they stopped not because of the equipment, because the very high temperature. No equipment can drill in this type, in this temperature. Then the temperature increases till it reaches 5000 degrees centigrade, which is near the temperature of the sun. You see here, this is a source that induces P wave and S wave. Using this, if I can record these waves here, and here, and here, and here, then I can measure distance, I can measure depths, I can measure everything. This may be silly a little bit, but what is important? I will tell you now what is important. Earthquake. You know that earthquake, when it happens in one place, it results in lots of waves. They tell you that this earthquake was recorded in this place. So what is important for me is to know the epicenter, which is the center of the earthquake, and the place where I record the waves. If I get a P wave or I get an S wave, I can analyze this to know what is the intensity of this earthquake. Sometimes an earthquake happens in Italy, and we in Egypt can measure it and tell them that the earthquake it measures at your place, say 6 degrees in Richter scale. How did we know? Using this type of analysis, because from the epicenter, waves will be shattered everywhere. Some of them will go into the mantle. Some of them will go into the inner core. Some of them will go into the lower core. And if I measure them all around, then I can measure everything related to this earth. So this is important. The other thing that is important for us also for info, do you know what is the difference between the magnetic north and the true north? There is a difference between the magnetic north and the true north. How can I know the magnetic north? I can know the magnetic north using a compass, البوصلة. I get the compass, I put it, it will give me a direction. Usually, I say this is the direction of the north. No, it's not the direction of the north. It is the direction of the magnetic north. But the true north, there is next time I will show you a figure that give you exactly what is the difference between both. But for this lecture, just know that there is a difference between both. This is very important for you. Sometimes you say that, okay, this is my compass. It says here, so I want to go to this place. This place is to the north, then I go this direction. No, you should not go this direction. You should shift with an inclination, an angle. This angle will take you to the geographic north. So it is important for us. It is a geological part, but it is important for our daily life. Maybe one day you will need to go to find your way using a compass. Unless you know the difference between the geographic north and the magnetic north, then you won't be able to do it. Here, the difference is about 11.5 degrees. This is the shape of Earth. If I get a compass, it will point this direction, while the geographic north is 11.5 degree to the left, to the right of it. So it is important to know where you are on if you are in South Africa, then it is not to the left, it is to the right, and so on. So it needs that you understand very good geography to understand this. But anyway, there is something called declination angle and inclination angle. The declination angle is the angle that we were speaking about now. This is the difference between the geographic and the magnetic north. The inclination angle is another thing. Sometimes the compass is not horizontal, it is a little bit dipping down. This is something I need. I don't have the figure with me now, but I will show it to you next time. It shows you what is exactly the difference between the inclination angle and the declination angle for the for the compass. It helps in geography. It helps in marine works. If you are going, sailors going in ships, they need to know this information. Okay, I will just, I will not go deeper into this. This is just our introductory session for geology. Next time we will go into parts of this lecture and our first part, our lecture, first lecture in geology. This time we are just considering it an introduction for the importance of geology and geotechnical engineering.